Okay, in this video we're going to look at finding a polynomial given the zeros of that polynomial. One thing that you need to know before we get started on this is the conjugate pairs theorem. The conjugate pairs theorem says that for a polynomial with real number coefficients, imaginary zeros occur in conjugate pairs, okay? So that means that if you have a zero that's in standard form for an imaginary number like a plus bi, its conjugate, a minus bi, is also a zero. Okay? To get a conjugate, you just take the imaginary number and swap the sign on the imaginary part. Okay? So let's see how this works. We're going to look at a couple of these. You'll write each zero as a factor, and then you're going to multiply them together and then simplify what you get. So we've got an example sitting right here. We'll write a third degree polynomial that has the following zeros, negative 3i and 7, okay? So using the conjugate zeros theorem that we've just talked about, what is the third zero that we'll need to write this third degree polynomial? We've got one imaginary zero right here, and so we'll also need to have its conjugate for another zero. And that conjugate's just going to be 3i, okay? So here's my zeros. This is the way I keep it together. I organize it in a little table. But you can do it a different way if you like. I'm going to get x plus 3i, x minus 3i from those two, the conjugate pair, and then x minus 7 from the one that's real. Oh, and I just totally wrote those in the wrong place. I am so sorry. That was so dumb. Okay. Those were the factors. They should have been in the second column. Well, shoot. Sorry, I don't know where that came from either. Okay, so negative 3i is given. 3i we know is there because of the conjugate zeros theorem, and then 7 is our third zero, okay? And as I had a minute ago, x plus 3i, x minus 3i, and x minus 7. Okay, those are my three factors. So what we'll do is we'll put those together, and then we're going to multiply them out. P of x is equal to x plus 3i times x minus 3i times x minus 7. And it is a smart thing to do to go ahead and multiply the two conjugate factors together first. Because what's going to happen is these two terms, when they multiply together, you're going to lose the I completely. The reason why that happens is because we are using conjugate zeros because we want our coefficients to all be real, okay? And if we didn't have that conjugate pairing, we would wind up with some imaginary numbers left behind. So if I multiply those two together by FOIL, x times x, then x times negative 3i for the outer terms, times positive 3i for the inner terms, and then negative 3i and positive 3i multiply together for the last term. I hope everybody remembers what to do with I squared, okay, from way back in P6. That's going to turn into plus 9, because I squared is equal to negative 1. Negative 9 times negative 1 would be positive 9. All right, so we can see what happens here. These two are going to add out to 0 when you try to combine them. So you wind up with x squared plus 9 for that polynomial once you simplify it. And then again, I've got two binomials to multiply together. So that comes together pretty easily. X squared times x, negative 7 times x squared, 9 times x, and then 9 times negative 7. We don't even have any that we have to combine at this point. That is our solution. Okay? So you make the zeros into factors, and then you multiply them together and then simplify as much as you can. Okay? This time we're going to work with a fourth degree polynomial. And so I'm going to write down my zeros, and then we'll make factors out of them. 1 and negative 3 are given. So is 2i. So if 2i is given, what is my fourth one? That's going to be that negative 2i, which is your conjugate. Okay, now make factors. X minus 1, x plus 3, x minus 2i, and x plus 2i. You can can put these in any order that you want to, but again, I would recommend that you multiply the two i's together first. And so I'm going to move them to the front. X minus 2i and x plus 2i. And then we're going to have x minus 1 and x plus 3. If you want to do, if you want to do the multiplication for the first two together and then the last two together at the same time, you can. I'm going to kind of take it one thing at a time as I go through. Now the two imaginary conjugate factors are going to give me x squared plus 2ix minus 2ix minus 4i squared. And then I've still got these two to multiply together. All right, this is going to be plus 4. And so when we simplify, this first part becomes x squared plus 4. And then you can multiply whatever order you want to here at the end. I'm going to do the x squared plus 4 times the x minus 1. So x squared times x is x cubed. And then x squared times negative 1, negative x squared. 4 times x for the middle terms. And then 4 times negative 1 for the constant. Can't simplify that in any way. And so now we'll take the little binomial through that 4-term polynomial. And what I'll do first is just distribute the x, okay, this x right here. It's going to go to all 4 terms. So we'll have x times x cubed, x times negative x squared, x times 4x, and x times negative 4. And then do the same thing with 3. 3 times x cubed, 3 times negative x squared, 3 times 4x. I'm about to run out of room, so I'm going to scooch over just a little bit so I've got enough room to write it down. And then the last one is negative 4 times 3, so negative 12 there at the end. Now we need to combine like terms. Got x to the 4th. I have 2 x cubed terms, and that's going to give me plus 2x cubed, and then a 4x squared and a negative 3x squared will combine to give me just a 4x. The minus 4x and the plus 12x will give me a plus 8x. And then I've got one constant, negative 12 there at the end. And so this is my solution. Okay, so now you've seen two.